day, welcome, tervetuloa, välkomna. I'll be speaking mostly in English, and but questions and answers in any language, chatting in any language is completely fine. Tänään ei aiota demota ja käydä läpi koko Veracoden pakkaa, mitä kaikkea sieltä löytyy. Tänään keskitytään tähän automaatioon, vähän hyvin kevyesti integrointeihin. Eli ollaan aika hands-on ja syvällä siellä itse tekemisessä. We'll start with welcome and introductions and just briefly go through what Veracode is so that the basic concepts are everybody is on the same page with that. Then we'll do some demoing and I'll go through a case and wrap up and discussion. So that's it. Speakers today is me, Thomas, and Julian from Veracode. Julian will present himself in a while. My main tasks are well, I do everything, but for this specific webinar, I kind of challenge myself. From a consultant's point of view, you usually tell your customers that here's the instructions, go ahead, you can do it. And as I said, I challenged myself and made sure that we're able to eat our own dog food and tried to do what you all are supposed to do. And that was in a specific case, and I'll be talking about that and what I had to face and what I had to find out. I'm not a developer. I've done some programming in the early years, but not for many years. So I had to do some investigation. But I'll talk more about that. Julian, shortly about you.
Yes, sure. Thanks for the first introduction, Thomas. Julian Caliber. I'm a solutions architect with Veracode for almost 6 years with Veracode now. My background is a lot of network security and application security, and I will run the part of the technical demo today, showing you around how you may automate your pipelines to do application security testing. So that will be my part today. I will talk in English. I'm not able to talk in Finnish. I'm sorry for that. If you have questions, as Thomas and Tapio already said, put it into the Q&A section or into the chat. Thank you.
Yeah, and as said, we want to keep this as hands-on and concrete as possible. So there's going to be real technology and real stuff, and not much else. Philosophical questions are encouraged and allowed, meaning you don't have to focus your questions on these specific technologies, but security in pipelines in general, and we'll try to tackle whatever you have. So we need to know two acronyms. One is SAST and the other one is SCA, and that's where the main focus today is. So SAST is Static Application Security Testing, or binary static application security testing, depending on programming language and technology. So what does it actually mean? Well, it means that when you package your application, you send it for upload it or send it for scanning. This is not a tool where you go through the code line by line and try to analyze it. The tool, the platform, creates a model of the application, and based on that model, it does injections and whatever, and based on those injections, it tries to track what happens in the application. So it basically goes through the application, putting inputs and monitoring outputs, and through that modeling, it'll find the flaws that it's able to find. Sure, there's some specific line by line analysis. If you have hard-coded passwords, you don't need much analyzing for that. It's either a hard-coded password or it's not. So those findings will be there as well. But that's shortly about how static application security testing and scanning works. So we step through the application, and if we have the frameworks available, which we usually have when you package the application, we'll be able to track all these paths and data flows throughout the complete application, including the frameworks and whatever libraries is there.
The important part, sorry, if you can go back one slide.
Yeah, sure.
The important part to remember here is if we think about non-compilable languages, because we were talking about binary static analysis so far, this methodology of binary static analysis is applied to all the languages we support. It doesn't matter if that is a source-based language like JavaScript that you cannot compile, or if that is something that you can compile like Java or C# or C++. So the methodology will always be the same. Doesn't matter if you scan a source-based language or a compilable language.
True. Binary in this sense is it may take your thoughts in the wrong direction, but that's a good comment that of course JavaScript is not binary and will never be. SCA, software composition analysis, and in layman's terms, libraries. So this is where we look at the application and find all of the third-party libraries imported and included into the application. And that's another part of this. It's equally, if not even more important, as you, depending on your programming language technology that you're using, you may be importing I've seen up to 3,000 libraries imported into a software. So it can be quite huge. The percentage of code included in an application, which is third party, is actually quite huge nowadays. And we're going to be focusing on the latest edition of this, which is the agent-based scanning, which gives you the most and the best insight into what you have. There's this neat thing called vulnerable methods, which is available in the agent-based scanning. That's important for risk management and for planning what to actually do, instead of just having to focus or rely on whether we are going to fix medium, high, or critical. We can actually focus on fixing and updating and patching libraries where we are actually seeing that the methods that are vulnerable in the library is actually being used or triggered in the application. So that's a very important part, and makes a big difference if you have thousands of libraries and you need to make a decision. What do we actually fix? For today, the black boxes here is the scope of what we're doing. I think Julian will quickly show something related to the IDE integration, but that's basically just for kicking off the demo, so we won't be going into how to configure your IDE or anything. The platform consists of three basically engines. SAST, as we talked about, SCA, we talked about that. There's also the third part, DAST, which is the dynamic scanning. Think of OWASP SAP on steroids. As we're going to be talking about automation, we can automate almost everything. The platform itself, of course, covers more than just the technical scanning, like governance, analytics, metrics, trainings, and overviews. The software security program basically lies on the platform, so it's more than just scanning. But SAST is used for pipeline scanning, for sandbox scanning, and for policy scanning. Julian will talk about those a bit more. We will see concretely how that actually goes. And And SCA, the technology, is used for both library scanning and container scanning. So we will be using this. This is terminology. We can come back to this and ask questions if needed. And Julian, take it from here.
Yeah, thank you, Thomas. Thanks for setting the stage. And if we look at this slide here, that should help you to understand how flexible Veracode can be integrated into your pipelines. There are a lot of things on this slide. Let me start on the left-hand side with the blue boxes, my code, our code, and production code. This is how we actually order the different type of static scans or software composition analysis scans into your SDLC process. When we start with the production code, or when the code is moving from our code into production code, we can see the policy scan. The policy scan is rating your findings according to a security policy that is set up on the platform. You may want to tell developers they only need to fix very high and high severity findings, or you may want to rate the results of a scan according to OWASP standards or to PCI standards or something like that. So as a developer with the policy scan, you should see a red shield or a green shield if your application is compliant to your policy or if it's not compliant to the policy. That shield can be used as break build information in your pipeline. If you think about the policy scan only reflecting your master branch, if that comes back with the red shield, you're not allowed to deploy the application or ship the application, because there are still flaws open that security wants you to fix. These policies are usually not created by the developers, because as a developer, you don't care about security requirements, but you want to know what security wants you to fix. So at the same time, as a developer, you don't work on a master branch, right? You don't touch the master branch code directly. You work on feature branches. And this is where you actually code, where you do your unit tests, or where you do your security tests. And that's how we support you in providing this sandbox scan technology. The scan engines, by the way, for policy scan, sandbox scan, pipeline scan, or even IDE scan, in terms of static analysis, they are all exactly the same. If you upload the same code, they will find exactly the same flaws. Exactly. Thanks for going back.
Yeah. It was there. Yeah. Go ahead.
Exactly. So the sandbox scan will reflect your feature branch. If you think about the process, the least scan you do is a policy scan, because you only do that when you merge your feature branch into the master code. But you want to have developers to see all the flaws in early stages. So you allow them to run security scans, static application security testing, and SCA scanning, software composition analysis in earlier stages. At the feature branch stage, you're not breaking anything. You encourage developers to scan as much and as often as possible to see what is actually required to be fixed in order to achieve policy compliance when you run the policy scan later on. So at that stage, the results come back with a red shield or with a green shield again. Both of that, policy scan and sandbox scan, both run inside your pipeline. And don't be confused by the next stage, the development branch or my code, where you can read pipeline scan. Don't be confused by the name, because even if that is called pipeline scan, doesn't necessarily mean that's the only thing that runs on your pipeline. All the three or four static analysis or three anesthetic analysis types, policy scan, sandbox scan, and pipeline scan, they all run on your pipeline. Pipeline scan is named pipeline scan because it only runs on your pipeline. There's a very specific purpose on the pipeline scan in very, very early stages. It was built in order to give developers the fastest and quickest feedback on findings in static analysis. Because everything that the platform does, what the policy and sandbox scan rely on, is completely stripped out for the pipeline scan. And that's why there is no much of heavy tasks in the background, like mitigation checks or policy evaluation in first place. So the pipeline scan is raw, static engine work, and it will give back static, raw static results to developers in very, very early stages. And that's why the average scan time of a pipeline scan is 90 seconds, whereas the average scan time of a policy or sandbox scan for exactly the same code is 8 minutes. So depending a bit on the application you're testing, the code you're uploading, you could run the pipeline scan with every single commit actually, and giving developers very early feedback on every single commit. Now, I have said before, the pipeline scan is raw engine work, and there's no relation to a platform, to a policy or something. Well, you can download a policy file and also rate the findings of a pipeline scan according to a specific policy. In addition, you may want to only look at the net new findings for that very specific commit of the developer. So there is a possibility that you can download all the findings that have been previously identified with a policy scan or a sandbox scan, and also sort those out when you run a pipeline scan. And in that case, if you rate by policy and sort out all previous findings with a pipeline scan in the developer branch with every single commit, you can report on net new findings only in that code developers have submitted that time. So with that information, you have the fastest feedback or the earliest feedback to developers when you look at static code analysis. In terms of breaking the build, I think I said it before, you should not break in our code or in my code. Because you don't want to block developers, right? You want them to consume the results as early and fast and much as possible. So you may start introducing pipeline break build configuration when you merge your feature branches into the master branch. The merge will automatically trigger a policy scan on our side. And when that comes back with the red shield, meaning there are flaws open you need to fix, that's the time when you actually break your pipeline or break your build. All right, good.
Show us how it's done.
Exactly.
All the heavy lifting. Great.
Good. Let me start sharing. You need to stop first, Thomas, before I can start. All right. And let me share this one. So you see the same slide again. We're not talking about this again, but we start with our IDE here. So in my IDE, in Visual Studio Code, I have a project, which is my Vera demo project. And well, of course, as a developer, you can download the results of findings into your Visual Studio Code. So let's assume you did a few scans and there was something found. Here, for example, there's a finding about improper neutralization special elements used in OS command injection, whatever. So let's assume you did some scans, you want to fix something, and let's assume by just changing this comment, saving this file, I fix a security defect. Just talking about that very briefly, because I need to kick off a scan, right? I need to do something here. All right, so in my case, I'm actually working on my development branch. So let me commit this file into my development branch here, where I'm actually working on, and push that into my pipeline. In the background, this is configured to go into GitLab, because that's the most configured system on my side. But it really doesn't matter if it is going into GitLab, if that is going into GitHub, if you do that with Jenkins, if you do that with Bitbucket, Azure DevOps, it really doesn't matter. You can just do it everywhere using our APIs, our API wrapper, or maybe our plugins. So, all right, I'm on GitLab here. I have just committed code into my repository here, and that should automatically trigger a pipeline. So that is my development branch pipeline that was triggered by the commit. And before waiting here to finish that, because, well, you need, I need to download a Docker container. I need to compile my application. I may start a Docker container. So that requires a bit of time, of course. But I want to show you how that stuff works, right? So let me jump back here and go into my development pipeline that I've just run around an hour ago, and that already finished. So in that case, you can see I have done a few things. I have a few stages in my development pipeline here. I have a build stage, I have a security scan stage, I have a deploy run stage, and I have a dynamic analysis stage. Well, questionable if you really want to run a dynamic analysis with every single commit. Most probably not. But that's just a demo and should show you the flexibility we actually have and how we can integrate that. So we first of all, we don't care about pulling a Docker container here. We don't care about the compilation, because that is completely different in all your applications, of course. What we really care about is the static analysis. And in this case, I've run this so-called pipeline scan here. In my case, it is configured in a very specific way, and there's a lot of stuff coming back. So let me scroll to the top here and explain you how that is configured. In my case, the so-called pipeline scan it's just a little jar file that you can download and run in your pipeline. You need to provide API keys here to log in. But the first part I'm doing is to download a policy file here, because the pipeline scan has no relation to what you do on the Veracode platform. It most probably doesn't know anything about the pipeline, the policy. So I'm downloading a policy file here that I would like to use in order to rate my findings. So that's the first part I'm running here in this stage. The second part is to actually run the pipeline scan and upload a file to the pipeline scan, which is my Java application. It's a Verademo WAR file. I have a few things configured: issue details true, GitLab issue generation true, GitLab vulnerability generation true, and so on. The important part here is about the policy file again. That's the name the download comes back with, and then it will be used in order to rate the findings. I also have upfront created a so-called baseline file. And with this baseline file, I am sorting out all the previous findings of a policy or sandbox scan, because I don't care about them in this stage. I want to see net new findings of that code that I just submitted here. So you see all that information again here, named what is done. And then what we can see when the scan is run, well, by the way, it started 6:26:44 and it finished 6:27:38. So it's not a full minute in terms of the time, how long that run. On the platform with a pipeline, with a policy or sandbox scan, this application takes between 4 and 8 minutes to finish the scan. So we see what happens here. We analyze 2 modules. We have identified the Java code here. We have also identified JavaScript code here. We have found 146 issues with that policies, with that pipeline scan. But only 13 issues in high severity are actually shown here. It's CVE 89. It's a SQL injection that is happening in user controller Java line 166. We also show you the information why we think that is a finding. That is the long notation. You can also turn off to show the details and just show that line of code where that is identified. But the long notation also tells you about why we believe that is a finding. The first argument to execute query contains tainted data from the variable SQL query and so on. So you have that information here. If I scroll a bit further down, we can see there were 92 issues of medium severity, but we skipped them, or 20 issues in low severity. We skipped them as well in informational, according to my policy that I download, because my policy is set up to only rate high and very high severity findings. So even if there were findings in other severities, we don't tell you about that. You don't need to know them because, well, you don't need to fix them in that case, because security only wants you to fix very high and high severity findings. So 13 new flaws were found, and that is net new compared to what was scanned before and what was identified before. So in my case, I've sorted out all the other findings we have already seen with other policy or sandbox scans, and that is net new in my code of my pipeline scan here.
So Julian,
yes.
A quick question, because earlier you said that the policy scan is about the policy and the pipeline scan is about raw brute force SAST findings. And here you're actually downloading a policy file, so you're still doing some filtering locally in the pipeline based on that policy file. The difference, did I understand it correctly? The difference is that the pipeline scan is never uploading anything back to the platform for any purpose.
That is absolutely correct. Yes, the pipeline scan only runs locally.
Yeah.
It's just a let's say temporary view of that very specific piece of code you are uploading here, and is not uploading anything to the platform. So that is not part of the general overall governance approach we also put in place with Veracode, beside just the technical static or dynamic analysis or software composition analysis. It's built to be a very quick feedback tool for developers to report on net new findings with single commits.
Yes, but you can still filter using a policy, so you don't have to look at 1,000 informational low-level findings if you have those. They will not be bothering you in the pipeline either. So it's
exactly. It's always about prioritization, right?
Yes.
I mean, we can show all these 146 findings, but you, as a developer, you're most probably not interested in what you don't need to fix. So you can still rate them and filter according what you want developers to actually fix. So giving developers only the accurate results and prioritize for them upfront.
Excellent.
All right, so that is the pipeline scan. When we look at the results of a pipeline scan, well, we just have looked at a command line output. Well, that's maybe okay-ish in many cases, but you may want to see it in a different place. So GitLab offers the possibility to create this security tab here. And if you open that security tab, you see 138 vulnerabilities from SAST scanning here, for example. So if you look at those SAST information, you can just click that and open that information. Oh, that's, by the way, exactly the same we have looked at just before. So that SQL injection is going going into user controller Java line 166 with the description again. As a developer, you can click that here and you jump into the code right away and see the results from here as well. The pipeline scan also has the possibility to create issues on your issues list, because the security tab is only able to show when you have the biggest GitLab license, the ultimate license. So let me jump into something further down here. So a pipeline scan result issue would look like that. And you can, again, click that. You see the description with a bit information here. You can just go into the file again and open that and look at the Java file and the line of code where exactly did that happen. So that is, yeah.
Yes. So if you're a user of Veracode already, of course, you would have been on the platform. You know how you can triage flaws. What you just showed there with the list is basically that triage flaws, the findings of that in your GitLab.
Exactly.
Yeah. So it brings the stuff. You don't have to go to the platform every day to look at those things. The developers can stay inside the build tool in this case.
Exactly. And that's what we always suggest. Developers should stay where they work. They should not learn new stuff, but you should automate and should stay in the tools where you already work on your day-to-day basis anyway. All right, let me jump back here and go back into my pipeline jobs. So that is the first part of static analysis, which was the pipeline scan. I also run my software composition analysis here on my application itself, looking into the third-party components of my application. Or as I'm building a Docker container here, I'm also running the third-party component analysis on my Docker container, looking into the operating system components. So when we click that, the command line output is not that nice anymore because I'm running a specific thing here in the background that is automatically creating issues for you again. So we display all the issues that will be created here, and as well, on the security tab here, you also have the dependency scanning vulnerabilities. And I can just select here dependency scanning. And when I look at one of these issues, you can already see where that is happening in dbus glib in that versions. It's used in your application, and it's having that CVE attached to it. So we are not, again, showing that just in the security tab where you may need the biggest GitLab license. There's also the possibility, let me jump back into that window here. There's also that big list of issues where you can see these findings again with the dependency issues. They are tagged with dependency scanning here and with the specific severities. It looks exactly the same as before. You can much nicer configure here and structure the output, but it's exactly the same output that you have seen before. And you see where that is invoked from file name utils normalize. This is where the Apache Commons IO vulnerability is getting into your application. So the static analysis, pipeline scan, and software composition analysis, they all will create specific issues for you if you want to. You can not only show that in the security tab or in your issues list, you can also import all that stuff into Jira, for example, if you want to create tickets around that. Maybe questionable in that early stage in your development branch if you already want to create tickets. Here, and you just want to consume it from here. But let me jump back into the pipelines again that I've run an hour ago, where you can see my development, my release or feature branch, and my master branch. So if I go into my release branch here or feature branch, there's another stage which I called scan reporting. because in this case, I've run a sandbox scan here. And when we look at that sandbox scan, there's a bit more that is coming out here, or there's something running in the background, so I just choose the wrong one. Well, doesn't matter. But this is just kicking off a sandbox scan on the platform, and there is a report generation after that is creating my static results again. So in the next stage in my sandbox scan, I've already fixed stuff. And here we just have 3 vulnerabilities left over because I have fixed a lot of stuff, or maybe I have remediated or mitigated a lot of stuff. So there's still something open, like the OS command injection here in Tools Controller Java line 94. I can jump into that again. And of course, we are also creating issues on that information on your issues list here, and they are tagged with static code analysis. So you can always sort that and review all that information here, or again, create your Jira tickets in order to look into that. All right, so that is how my pipeline is structured. To show you the full pipeline with all the different stages where you can integrate, let me jump into my GitLab CI file and show you the pipeline editor and the visualization of it. So I have all these stages that may run in different stages of my SDLC. Well, build will run all the time, but maybe software composition analysis runs on a very specific stage. Well, pipeline scan definitely runs on a specific stage. Sandbox scan runs on a specific stage. Policy scan runs on a specific stage. Then there's a statistic generation, a static report generation for a sandbox scan, for policy scan. I may commit something back into my development pipeline, because here I'm actually generating this pipeline scan baseline file based on a policy scan, because I want to sort out everything that was found here when I next run the pipeline scan. So that's what I'm doing here, actually, creating a new baseline file and committing that back into my development stage. And I start a Docker container. If I start that Docker container, I know I have a live running web application, and I can automatically kick off a dynamic analysis into that live running web application here, because I know where that is running. So everything in terms of static analysis, static, software composition analysis, and dynamic can be completely integrated into your pipeline and into your SDLC. And that's where I would like to stop and hand back to Thomas, unless there are any questions, of course.
We are overwhelmed with details and understanding our own limitations. No, I guess in the audience, people from various stages and at various, let's say, maturity of how to do this. I think we can all agree on that you have spent quite a lot of time on perfecting this, including the housekeeping, basically syncing with your latest production release, meaning your policy scan, and backtracking that to the development branches and so on. And it's hard to see why it would not pay off to do all of this to assist in the actual development phase as much as possible.
Yes.
Because the housekeeping thing it's a one-time thing, and once you get that up and running, it will immediately reduce the amount of clutter the developers need to see and bother with.
Exactly.
Because it's go ahead.
Yeah, because you always want to provide as accurate as possible feedback to developers. We don't want to annoy developers with 10 million findings. It's all about prioritization of findings. You will never fix everything the same time. So you should prioritize, and you should maybe tell them what is net new in their commit, so they can start fixing that, because they are actually working on that commit.
Because it's always very easy to see at the perfect execution and thinking, well, I could do that. And basically that was what I set myself up to do. and I did not reach the level of maturity that we actually saw there. But my mission objective was to get everything scanned, and what that even means is one of the takeaways I would say from this is that plan what you actually want to scan, where and how, because otherwise you will end up with a pipeline that every time does everything, and that's most likely not reducing the clutter and not prioritizing anything. So there are a few lessons learned here. I'll run this because we already seen all the pipelines. I'm just going to quickly run this through the in PowerPoint for you. It's also a case, so I would not be able to show you the live environment. But this is basically where I started. I had something that built something, and it pushed it into development and pushed it into production, and that was basically where the development left off. And then I had to add the security on top of it, and that's what I tried to build. And so that's what I had, and that was where I was going. I already talk you through that. So here, and the philosophy behind how this software was built was that it creates a container and it puts all of the stuff into the container, and then we're done. Basically, the during the pipeline, actually never see the software itself being built. It's being built as a part of the container. And well, how do you scan that? Well, okay, of course you can throw the container scan at it, but that would not then be at all the same scope that we want to. So I had to sort this out to start with. And let me remember, this was a real life case. So of course, what it meant that I had to build the software specifically for scanning in addition to deploying a container. So the correct image always to build from is of course important. In this case, it was a node application, so we chose a node. And yes, I did some trial and error. I will tell you about that. Basically, build it. This is built using NPM, so nothing fancy or specific there. One thing that you need to know about NPM is that you need to run the shrink wrap command to get your package lock JSON, to get your scan and upload SCA results. And so that's a thing you may necessarily not be doing in your production run, but when you want to start scanning, that could be one of the reasons why you're not getting any results. Hint, hint. And a revelation, of course, I was looking at the documentation, which is the way you do this. And the documentation says, in not so many words, but for JavaScript applications, just pack everything into a zip file and make sure that you have your node modules here and there, and everything starts from the root and this and that. And the trial and error part is pretty much about that. I tried to create that and proved that you can just run npm pack, and that doesn't really create what the documentation wants you to have. It's a tar gzip. It's the directory structure is not exactly, but it works. So if you want to package JavaScript files, you have npm to your that you can use. Then just those three commands is basically what you need to do, and you'll have whatever you need to be able to go onwards in your pipelines. Collecting artifacts, of course, is something that we then when again, it always starts with choosing a compatible image. So we had Node. Now to run the pipeline scan, we need something that has Java enabled. Julian already walked through pretty much of what we have here, but basically, yes, you're downloading the actual scan command, and then you run the scan. That was what Julian showed you, and store the output for later. So what you saw in in the previous demo was that these files were downloaded, and by naming them in a certain way, they will be integrated into GitLab in a neat way. And in addition, of course, you can download them directly from the pipeline if you need those raw results. For SAST, pretty much works the same way. You're again going to download that a file, which is the command you're actually running, and then you run it, and then so it's basically over and over the same thing we do here. Always a compatible image, the command, and then you run it. This is the library scan, so nothing fancy here. Again, you download everything, and or you make it available, and you store the files so that they're compatible in a way that GitLab in this case can use. And the Docker scan had some more quirks. To start with, you need to have the Docker in Docker service running, otherwise it won't fly. So that's one takeaway. Again, don't debug that any more than you need. Just run the service. If you run the Docker latest image, you won't have curl and bash in there, so you need to add them. Of course, with GitLab, this is really easy. You just add those, and you're done with that. And what I had to do in addition, because I'm not pulling the container that I'm actually scanning is not being pulled from a public repository. It's pulled from the local repository, and the container is built earlier in this pipeline. So I have to actually log in to the local repository and then pull it from there, and then run the SCA scan with scan parameter image, so that we're actually running it against an image. So there were some issues there, which just by following examples, which mostly focus on pulling images from public repositories, I had to work around that. And again, how does a non-developer, security-oriented person go ahead and start building this? Well, I started by copying a lot from Julian's repository on GitHub. Why not? Because it's there. And
it's public, so everybody can just access it.
Yes, sure. Exactly. Why invent something when there's Julian who already has invented it? So pick and choose from everything you need. Of course, the pulling and pushing of images locally, that I copied from the existing build pipeline, because the developers have already done a bit about the pushing and pulling, so I was able to reuse stuff there. Julian already showed you how you can use the artifacts and the reports. That's something this case would definitely need. Also having the findings back and more parameterization between, so that things would be more generic. And then when all is said and done, I would most likely end up refactoring the whole thing and making sure that parts that are slower, for instance, where I need to build a container and then do stuff, and that building the actual container in this case can take quite a long time, and but that's not the same as committing to the latest or committing to the development branch of the software. And so there would be things that I would like to run on a nightly or weekly basis, and something I would like to run on every commit. And basically I would pull out my pen and paper and redesign the architecture of the pipeline so as to make most use of the scanning tools and not hold up the developers. And because I, in addition to having stuff in GitLab, I like to publish it elsewhere. So I would also publish some of the reports, some of the scan results to Confluence automatically, just because I like to do it like that. But that would be the real life case how I go ahead with this. It's not really that difficult. depending on what build system you use, of course, there are small differences here and there, but the basic stuff that you need to do and configure once you understand how the Veracode tools work. Some tools may hide it behind a user interface. Some are like GitLab, where you just edit the pipelines directly. The theory is the same. There's not much difference. Of course, you saw here that Julian was packaging a Java application and I ran it with JavaScript. So there were some obvious differences there between that. But if you're a developer and you know your own programming language, then making a software package that is scannable is trivial to you. And just as one of the final notes here is that this is not a silver bullet. This is very good, very effective, but still you are not going to be finding things in SAS that you will with manual penetration testing. So that's still a thing that you need to do. Of course, you're not doing manual penetration testing and all of this on the outer circle here, like the threat modeling, risk assessments, and then if you need to do compliance reporting, set your requirements. Those are all things that you need to do. You need people to work with that. Security is not only the technology part, but then in the middle of that, of course, you should make use of automation as much as possible. Once you have your requirements, push them into the policy. Once you know your risks, use that on the platform to accept risk or make sure that you have a policy that highlights those things, and to make sure that you find your logical flaws, make sure you do regular penetration testing. And I think automation is king. That's what you need to when you start using build pipelines. You need to do automation, and almost everything is doable with what Veracode provides you, because there are the APIs and all of that. So and tools, so you can build it to look like the way your team and your pipelines need them to look. This is not a code quality tool, however. So in your pipelines, do add code quality checking tools as well. And prioritization. So that's really important, and create your requirements somehow so you know what your priorities are to start with, and then use the platform to manage whatever risk you want to accept. And for those who are interested in understanding how licensing works, well, SAST, SCA, and DAST, they are all licensed separately. Usually SAST and SCA are licensed together because it makes sense from a security point of view. One application is one license, and an application is a collection of logically related software components performing a coordinated set of functions. So that is the definition of what an application is. And with this one license, you get everything. You get all the features that you actually that you can use. So you can have an unlimited amount of use on the platform, single sign-on, unlimited scans. All programming language are included. All APIs are included, and whatever integrations you want, and you can imagine, it's all included. If you're interested in training, then e-learning and security labs, those are licensed on a per seat basis. And that's it for today.